And here we are again with another video on Hungry Turtle Code. And today, I thought we would revisit the video that I did over Christmas, which you can see in front of you, some nice falling snow, canvasy goodness. And at the end of that video, I handed it over to you guys and said, if you wanted to implement some gravity or wind or anything else you could think of, go ahead. So I thought today, I would go back to that video and I would implement some of those features. And I'll do it in the same style as I did that video, where I'll just turn on the camera and just kind of work away until either I've made way too much content and the video is way too long, or I get massively stuck and have no idea where to go, or just decide I don't want to do it anymore. So let's jump into it, jog our memory about what the code was that we were dealing with, and then try and implement some stuff. So we had this Christmas class, which has a setup function that just creates a bunch of snowflakes, and we just have this update method that gets called with request animation frame, and then that just draws the flake onto the screen. And then of course we have the snowflakes which implement the different acceleration velocity using this vector class, and then the snowflake itself has an update that changes the position based on velocity and the velocity based on acceleration, and then just does some wraparound stuff. And that's basically what we had. So in this video, we will continue from there. So I think the first thing we should do is make this wraparound a bit more robust. So step one is, right now, if anything goes off the bottom, it just appears at the top. But the flake doesn't change its acceleration or its velocity or anything. So if we implement gravity and we have something that's coming down from the bottom and it has an acceleration as it goes off the bottom, that acceleration will still exist when it comes in from the top. So that's not ideal. We kind of want it to look like a new snowflake as it comes in from the top. So we will add another thing here where we're resetting the position to 0, but we'll also grab this velocity and acceleration, and we'll reset the velocity to just the same random values as we had before, and we'll reset acceleration to 0. And then we want another check here, else if this.pos.y is less than 0. So this is checking wraparound from the top. So the thing that we implemented before, the snowflakes were just falling. But if we're going to implement other things, like potentially I'm thinking that we can implement a button click that attracts all the snowflakes towards the cursor. If we do that, we might have some cases where we need wraparound through the top. So we'll do the same thing. If it goes off the top, we'll just reset everything like so. So with that, if we go back to the browser, it should look like nothing's changed, but our code is a bit more robust now. So the next thing is the ability to apply a force, so gravity or wind. So we'll go into our snowflake and we'll add another method, and I'll call it apply force. And the apply force will take a force argument, and that force will be a vector. So then we can say this.acceleration.add force. If you remember, we have the .add on the vector, and that takes a vector, and we know that the force that we're applying is a vector, so that we can pass that in there and it will add our vector to the acceleration. So that'll be a force applied to the acceleration, and then in turn, that acceleration gets applied to the velocity gets applied to position, and we have some physics. So now we need to actually test if that apply force actually works. So in our Christmas, we will just do this.canvas.add event listener. We'll listen for clicks, and with that we will loop through all of our snowflakes. Snowflakes.for each flake. And then we'll go flake dot apply force, and we'll apply a new vector We'll just give it some hard-coded values for now. And with that, we should see some nice snow, and when we click, we get some wind. But this is some crazy wind. So we can see the wraparound working quite nicely, and we're getting this nice spraying effect as this comes through. But you saw that the acceleration just kind of blew up, and the velocity just blew up. We don't want that. What we want is the wind to be applied just once. And the problem here is that we're applying a force, which is a vector that's added onto the acceleration. And then that acceleration is added to the velocity. But we never reset that acceleration. So come the next update cycle, we're reapplying that acceleration to the velocity again. And then it's reapplied. So the velocity is just blowing out very, very quickly. And that's not what we want. So we want to reset the acceleration every time we do an update. So we'll come back up into our snowflake and we'll say this.acceleration.mult0. So we haven't implemented this mult, I don't think. So no, we have only got the add method on the vector. So we'll have another one, mult, and it just takes a scalar. So this is just going to be a scalar multiplication. So it just takes this.x, multiplies it by the scalar, and this.y multiplies by the scalar. So if we multiply by 0, it resets the acceleration, which is what we want. So if we save and go back, we should be able to hit, and we get some wind, and it's a very gentle wind now. Gentle wind that's just drifting across, which is good. We're not getting this blow up. So now, instead of hard coding this wind value, we should detect which side we clicked on, which side of the canvas we clicked on, and apply the force in that direction. And then also apply a force that is proportional to how far away from the center we clicked. So by that, I mean, if we click way over here to the right, it'll apply a much bigger force than if we clicked only just a little bit to the right. So let's do that. So we'll come back into our event listener, and then we will grab hold of the event, and we'll create a constant. We'll call it x, which will be event.clientx minus this.canvas.width divided by 2. Actually, we'll put this into a midpoint variable, because we might need it again. So we'll put this.canvas.width divided by 2. And then here we'll use midpoint. So this.canvas.width divided by 2 gives us the center point of the canvas. And then here we're saying the x is wherever we click, the x value of where we clicked on the canvas minus the midpoint. So what that'll give us is a negative value if we click to the left of the midpoint, and a positive value if we click to the right of the midpoint, and exactly a 0 if we click exactly in the center. So I'll just console log that out just so we can illustrate the point. So if we click here, we get a value of 395. And remember, this whole canvas is 800 wide. So 395 makes sense that we clicked right close to the edge, should be close to 400. And if we click over here, we get minus 390. Good. So this value is obviously in relationship to the whole width of this canvas. So we should normalize that so that it's easier to deal with. So I'll say normalized x equals x divided by midpoint. So now if we console log normalized x, the value will now be between 1 and minus 1. So if we click here, we get a value of just over 1. Okay. And a value over here, minus. Okay. Interesting that that goes over 1. But it doesn't actually matter, really. We don't really care, and I'm not going to dig into why. It's probably some rounding thing. I don't know. But the force here, we can now apply. We'll just create a scalar. And I'll make the scalar 10. Just made that up. And the vector will create wind of that scalar multiplied by normalized x. So remember, normalized x is between -1 and 1. So this scalar multiplied by that will result in a vector that points either from minus the scalar to plus positive the scalar, and it'll be 0 if normalized x is 0. So that will give us a wind force proportional to how far to the left or right we clicked. So if we come back and take a look, we can click there, we get a strong wind off to the right hand side. And then if we click to the left hand side, we now get a strong wind forcing all of this, but it's kind of nullified the wind here. And then we've got some lighter wind that we can apply by clicking towards the center. But one thing you'll notice here is there isn't any gravity. So we're applying a random downward acceleration to the snowflakes, but that's it. There's no extra gravity pulling down the snowflakes. So when we apply a lot of wind, we just get snowflakes that are kind of flying across the screen and not really being pulled down very much. So we want to apply a bit of gravity. So we'll come up here, and in our Christmas, in the update, when we loop through all of these, we'll do flake.apply force, and we'll apply a new vector, and we don't want any movement in the x direction, and we'll give it a small value in the y. So that's just a little bit of gravity. So if we come back into here, we can see that there's a bit of acceleration. We can see there's, as the flakes are spawning up here, they're a bit closer together, and then they're accelerating downwards. We could accentuate that effect by increasing the amount of gravity up to, say, 1, which is 100 times more, and we just get this sort of cascading waterfall effect. And, I mean, I can see this effect being quite useful in other use cases. Like, there's definitely other cool things that you can do with this, but for our purposes, I think there's a little bit too much force there. So we will reset that back to 0.01. So now we've just got this kind of thing going on. If we click, we get some nice wind, but the particles are also being pulled downwards when there's wind. It's not just going across, so it looks a bit nicer. So the next thing we'll do is try and attract everything towards the mouse, but we'll do it when we left click. No. So now I'm going to try and implement something that attracts the snowflakes towards the mouse if we left. So now I'm going to try and implement something that attracts all of the snowflakes towards the cursor if we right click. So right now we've just been left clicking and we get wind. So we get some nice wind if we left click, and we can even get some nice bands of wind if we do it like that. It's pretty cool, but if we right click, we want all the snowflakes to move towards the mouse. So that's what we shall do. So to figure out when we right click, we'll go up into our event listener, and we will have a switch statement on event.button. And then we'll have a case for 1, break, case 2, break. Just comment this out. I'm not actually sure what the syntax is, so I better just check. We'll just log out event.button. So I'll left click, we get 0, and right click. Oh, interesting. We just get the context. Is that normal? Let's go back to the event. Let's go back here. Interesting. Add event listener context menu. Maybe we'll just do it with the context menu. I'm pretty not sure why that's not working, but I thought that it was possible to do it with event.button, but for some reason the click event isn't firing on a right click. So I'll just do this.canvas.add event listener context menu and right clicked. Just console log that out, see if this works. Okay, so that works. So then I'll do event.prevent default. So I think that'll just stop the context menu from actually showing. And there we go. We can see we're getting some right clicks, but nothing actually showing up. But if we right click here, we still get the context menu. And then we'll want something similar to this, but we'll just comment it out for now. So what we're going to want to do is find the X and Y position where we clicked. So we can do that using client X, client Y, and then create that into a vector. So we'll say mouse vector equals new vector event.clientX event.clientY. And then we'll just console log out that vector. So then we can see we're getting a vector that is where we clicked on the screen, or where we right clicked on the screen. And this is why we used vectors. So what we're going to want to do is find out the angle from each and every one of these snowflakes to the point at which we right clicked. That could be a pretty tricky problem, but we're using vectors, and in vector space, to get the vector that points from one point to another, you just take the vectors for each of those points away from each other and take the negative of it. So I'm not going to explain why that's true. There's plenty of videos out there that do that, but we can do a subtract. So we'll create a subtract method here, and we'll give it a vector, and then we'll say this dot x minus equals vector dot x, this dot y minus equals vector dot y. And then where are we? Here. So then we could say, so we don't want to mutate anything here. So this would actually mutate. So let's create another method called copy that will return a new vector, this.x, this.y. Just doing this so that we can create an exact copy of a vector without, and then mutate that without having to worry about it. So I will say in here, this is where we want to do this loop. We'll just clean this up a little. So we want flake or const diff equals flake dot copy, and then copy dot subtract mouse vector, and then copy dot multiply -1. So now we're creating a copy of the flake, which is now in this, it's not copy at all, it's diff. Okay, so typos aside, we're making a copy of the flake, and then we're subtracting the mouse vector from that flake. So we're making a copy of the flake, then we're subtracting the mouse position vector, multiplying it by -1. So that should, if my memory serves me, that should give us a vector that points from the snowflake to the mouse. And then we can apply that vector as a force on the snowflake. So we could say flake.add diff. And hopefully that will work. So if I right click, flake.copy is not a function. Why not? Oh. Oh, yes. Okay, so it's flake.position.copy. So I'm missing a position in all of these. So flake.position.copy, and then that gives us that, and then flake.apply force, not add. I was thinking in vector land, but we're dealing with the flake itself, so we can just apply force. So maybe that'll work. So now we've got some snow falling. If we right click, we got some craziness going on. So I think we're going to want to scale the magnitude of those vectors. So, So I'll do diff.mult, and I'll multiply it by like 0.01. So I'll make it like much smaller and see if that works. There we go. We kind of got something going. It looked like it was mirrored though. Or is that right? I don't know. That's hard to say. It's kind of a thing, but I'm not sure if it's quite right. No, I think it's right. So I wasn't sure there if what we were getting was right. But then thinking about it, it is, because we've got gravity involved. So when I right click here, it feels like the focal point of where the snowflakes are merging together is down here somewhere. And that's correct because we have gravity, remember? So it's like when you shoot a gun, the bullet goes straight out, the force is only straight out, but the bullet will fall because of gravity. Even though the gun didn't apply a downward force in any way, it only like shot it across, but the bullet falls anyway. So when we click up here, the gravity will pull it down so that the focal point is down here. So we can try that now, and we can see the focal point is down here somewhere. And I think if we reset the gravity to 0, we can probably get it to work. So we'll just apply a 0 force there. And then we've got this. And then if we right click, we get the snowflakes coming out nicely towards where we clicked. And there we go. So we've got a nice effect going on there. So there we go. We've got that working. And if we just go back up and take a look at the code that we used to get the snowflakes to move towards the mouse, it's basically just this. It's 10 lines of code where we're just grabbing the X and Y position, creating a vector out of it, looping through each snowflake, making a copy, finding the vector from the snowflake to where we clicked using the subtract multiply by 1. Then we're just scaling it down a lot and applying it as a force. It's extremely easy. It sounds like a very complex thing to calculate the angle from every snowflake to a point in space where we clicked. And it should be, but this is why we thought about things ahead of time and implemented the vector class, because then we're dealing in vector space with vector mathematics and the problem kind of just melts away. Where if we had to do this manually, calculating the angle, it could be quite tricky potentially, but because we've implemented this nice interface of a vector things just kind of work. So with that, I think that's enough for today's video. I hope you enjoyed it. I hope you learned something. And if you liked the video, give me a big thumbs up. Hit the subscribe button, bell notification, all of that YouTube stuff. Check out my Patreon if you like what I'm doing. But until next time, stay hungry and keep coding.